Welcome to Plutus. And today we are going back to our NEET 2026 paper analysis. Last class में हमने 65th question solve कर लिया था. Now we're gonna solve rest of the questions. So back to them. So first आपको दिया गया है the pair of molecules that are metamers. So पहली चीज we need to look for what are metamers. Metamers are compounds having variable number of carbons around a functional group. Variable number of carbon atoms around a particular functional group. देखिए यहाँ पर अल्कोहल है असल में यहाँ पर OH की पोजीशन बदली है. फर्स्ट केस में आपको दिया गया है प्रोपेनॉल, सेकंड में आपको दे रखा है आइसोप्रोपाइल अल्कोहल. सो ये आपके पोजीशन आइसोमर है क्योंकि फंक्शनल ग्रुप ने जगह बदली है. देन हमें ईथर दिया गया है आपके पास मिथाइल प्रोपेन, मिथॉक्सी प्रोपेन, एंड देन आपको दे रखा है इथॉक्सी इथीन. ऑब्वियसली यहाँ पर फंक्शनल ग्रुप ईथर है जिसके अराउंड नंबर ऑफ कार्बन चेंज हो रहे हैं. तो मेटामर कौन है आपका? ऑप्शन नंबर 2. यहाँ पर फंक्शनल ग्रुप आपको दिया हुआ है कीटोन और यहाँ पर एसिटल, यहाँ पर आपको दिया है एल्डिहाइड. फंक्शनल ग्रुप ही बदल गया तो ये मेटामर हो नहीं सकते. ये अल्कीन है और ये एक अल्कीन है. ये पोजीशन, ये है चेन आइसोमेरिज्म, सो ये भी मेटामेरिज्म पॉसिबल नहीं. नेक्स्ट आता है हमारे पास आइडेंटिफाई द इनकरेक्ट स्टेटमेंट फ्रॉम द फॉलोइंग. P C2H5 whole thrice AS C6H5 whole thrice form d pi bonding with the transition metal. Yes, क्योंकि phosphorus and arsenic both possess d orbitals and d orbitals can overlap over one another forming d pi bonding. Nitrogen can form d pi p pi bond. Nitrogen cannot form d pi p pi bond because nitrogen have no d orbital. So this is the incorrect statement. Next, phenolphthalein is used as an indicator for titration of sodium hydroxide solution against standard oxalic acid solution. Color changes observed at the alkaline pH. So for this we need to understand that phenolphthalein in basic solution gives pink color. In acidic solution it will give colorless color. So at alkaline pH it will be pink in color. So final color should be pink. Yellow, phenolphthalein has no yellow color. Pink to colorless, not possible. So the answer would be 3, colorless to pink. Next, we are given a list of compounds and we need to mark them with respect to the number of sigma and pi bond they possessed. This is C2H4. Formula for CnH2n. CnH2n suggests that this is an alkene. An alkene possesses CH2. It has 1 pi bond, 2 sigma bonds with hydrogen, 2 sigma bonds with this, 1 with this. Total 5 sigma bonds, 1 pi bond. A should be 4. Whichever option has A in 4 will be the correct answer. Option number 1. Rest has A, option number 1, A on the third, A on 2. So that's why option number 1 is the only correct answer. Then at a certain temperature during a process, 500 joule of energy heat is absorbed by the system and work of 200 joule is done by the system. Total internal energy change. Internal energy change is given by delta U Q plus W. Heat absorbed 500 and work done by the system is negative work done. So it will be minus, which will give you 300. Sorry. It's 500, 200, option number 2, 300 joule. That's it. Then methane reacts with steam at 1273 Kelvin in presence of nickel catalyst. This is the process. This is used for preparation of carbon monoxide and H2 gas known as your syngas, which is carbon monoxide, option number 1. Next, a compound C8H2O gives orange red PPT with 2,4-DNP. That means the compound is actually carbonyl because carbonyl gives 2,4-DNP test. Then it does not reduce failing solution, which confirms that the carbonyl is actually a ketone. So whichever option does not have a which have other functional groups other than the ketones would be eliminated, which is this one. Next, on drastic oxidation with chromic acid, P will give you an aromatic compound which will Q, and Q produces effervescence. Effervescence means there will be bubbles and it is reacting with a base. So whenever a carboxylic acid reacts with a base, CO2 is produced as a byproduct. So that means the final functional group will have a carboxylic acid functional group. Now, this also possesses a functional carboxylic acid, this also, but this is actually what? This is a ketonic, but on oxidation, carbon dioxide will be lost from it. So the correct answer would be option number 2. Next, we have a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. Mass of copper deposited at the cathode would be, this is the case of using Faraday's law. So we have copper sulfate, molar mass of copper is provided, 1 farad is provided. So for copper sulfate, we have Cu2 plus, which require 2 farad of charge to get reduced. So 2 farad of charge will give me 1 mole of copper, which is 63 gram, which will give me 2 farad. Let's find the charge. Q will be 10 minutes multiplied by 1.5 second conversion 60. The total amount of charge that I have, it is 15 into 60. 15 into 60, 5 6 are 30, 80. This is 800. So 800 coulomb of charge. So 2 farad of charge, which is 2 into 96500 coulomb, will give me 63 gram of charge. So that means 800 coulomb of charge will give me 63 by 2, 96500 multiplied by 800. 800 divide this and this, 2 goes by 4. This is 6 4 3s are 12, 6 3s are 18, and that's going, sorry, 4 6 are 24. This is 252 by 965. Now let's make them close to roundabout. Round, this is, let's suppose this is 250 and let's suppose this is 950. So 950, it should goes by 25, will give by 10, 25 by 3 will give me 75. Let's say 250 by 100. It should, if it would be 1000, it should be about 0.3, because if it would be perfectly 250 or if it would be 1000, then that would have been a classic 1 by 4, which should give me 0.25. But here the denominator is smaller, so the numerator value will increase. So the answer should be greater than 0.25, greater than 0.25, greater than 0.25, option number 4, 0.293. Everything is greater than that. Functional group that can be identified through the phenolphthalein dye test would be, functional group that can be identified through the phthalene dye test. Phthalene dye test is only applicable for phenolic functional groups. Then correct statement regarding to the secondary structure of DNA and RNA, that is, DNA possesses a single strand helix. No, DNA is double stranded. RNA possesses a single strand helix. RNA and contains thymine. RNA do not contain thymine, it has uracil. Option number 3. DNA has double strand helix and contains thymine. That's perfect. Then this is the option number 3. Identify the correct statements. The molality of 2.5 gram of ethanoic acid, molar mass 60, 75 grams of benzene solution is 0.56. Let's check. We need to check molality. So 2.5 gram, molar mass 60 by 75, conversion rule 1000, decimal by 10, 25, 300, 100 by, that's 100 by 180, 0 0, 10 by 18, which will be 5 by 9. It will be 50.45 something. It should be point 8, 10, 18.5. It should be, sorry, 0.55 something. So yeah, option A is, this appears to be correct. Molarity of a solution 5 gram NaOH, molar mass 40 in 450 ml, 1000 by 450, 0, 5 goes 9, 100, that will be 10. This is 10 upon 4 nines are 36. 4 nines are 36, and it says solution is 0.278. 0.278, 10 threes are, that's 36, 10, 0, 0. 2. Here it appears to be true. B. Then aquatic species are more comfortable in cold water. Yes, because the oxygen content would be higher. Solubility of a gas increase with decrease in pressure. No, this is a violation of your Henry's law. For binary mixture of A and B, the number of moles of A and B are Na and Nb respectively. The mole fraction of B, no, it is given Xb equals to Na by Na plus Nb. Na cannot be here, so this is also wrong. So statement A, B and C are the only correct. So option number 2 would be the correct answer. Next we have, the mixture of chloroform and acetone forms a solution which gives a negative deviation from the Raoult's law, and it is because of formation of hydrogen bonding between the acetone and the chloroform. Why? Because of the presence of 3-chlorine, the bond polarity increases and hydrogen becomes positive charge, which can form hydrogen bonding with the acetone. So option number 1. Then at 298 Kelvin, a certain buffer solution contains equal concentration of X minus Hx Kb for X. Is this? What should be the pH of buffer? pH of buffer is given by Haselbalch equation, which is given by pH of a buffer will be given by log of concentration of salt by acid, salt by acid plus log of Kb. It should be this. 298 at a certain contains equal concentration of X minus and Hx. So salt and acid have same concentration. This value will become what? Log of 1 will become 0. So you are left with 10 power raised to minus 10. Buffer solution equal concentration of X minus, and you are provided with Kb, not Ka. You are provided with Kb. So that means this solution will give me a value of POH, not the pH. So it is log Kb would be 10 power raised to minus 10, which will give me POH equals to 10. For pH it will be 14 minus POH, which will give me a total value of 4. So the correct answer would be option number 3. Next, identify the incorrect statement from the following. The IUPAC name of the element with atomic number 107 will be unyl septium. Wait, un is correct for 1, nil correct for 0, but septium not should be. For 7 we use hep, so this is wrong. Largest and the smallest species among them is Mg, Mg2 plus Al. The largest and the smallest among, and Al3 plus R. The largest size is aluminium. No, it cannot be. Why? Because aluminium is a p block element. P block elements always have a smaller size compared to your s block elements. So the largest element should be magnesium actually. Then, oh, the incorrect statement. Yes, so the incorrect statement will be this one, because the question asks the incorrect statement and it says that aluminium is the largest. So yes, this is incorrect. Next is Correct order of increasing of metallic character. Metallic character increases left to right hand side. Sodium metal, base metal. So whichever we have three options, then it should be magnesium. Silicon is not a metal, so option number 4 out. Then sodium, magnesium, beryllium should be yes, and that's it. Beryllium, it says phosphorus, option number 1. Then correct IUPAC name of the following compound. Naming the carbon groups of the following compound would be numbering in such a manner that the groups get the lowest possible position. So first mark 1, 2, 3, 4, 5, 6, 7. Other option I can mark from the lower side, it would be 1, 2, 3, 4, 5, 6, 7. From the numbering right to left hand side, I find that third position has methyl group and fifth position has ethyl group. As per Lewis-Loken rule, 3 plus 5, it is having a total value of 8. While on the numbering of left to right hand side, ethyl gets a position of 3, methyl gets a position of 5. Lewis-Loken rule coming both same for both here. Then numbering priority should be, numbering priority will shift to the alphabetical order. So alphabetically E comes first. So hence the name ethyl would be named numbered first, which is 3 ethyl 5 methyl heptane. Next is you are provided with some 10 complexes and asked for geometry. Platinum always forms square planar complex no matter which ligand it is binding to. So A should be 3, whichever option has A equals to 3. This one has not, this one also not. Option number 2 and 4 has A equals to 3. Then NiCl4, weak ligand always form tetrahedral with nickel. So option number C should be 4. C should be 4. C is in 4. C is 1 in 2. So correct answer would be 4 for this. Now, for the certain reaction R product, the plot of concentration of R versus time has a negative slope. How can you predict the order of reaction? So first thing, order of reaction, we are provided with concentration with respect to time. So let's look for equation. A is equals to A naught concentration A. For zero order, we have A naught minus A equals to KT. Concentration in graph of A would be A naught minus KT. So here this has 0. For zero order, we are seeing that this is a negative slope in front of K. A with respect to T, equation y is equals to mx plus c. So A naught is the intercept, so it is a zero order reaction. Then finally, which of the following is an ambidendate ligand? All ambidendate ligand has a condition. Ambidendate means that they should have two donor sites, but only one would be used. Oxalate is a chelating ligand, so it cannot be ambidentate. Ethylene diamine, another chelate ligand, it cannot be. Ethane diamine, ethane diamine is EN, which is also a chelating ligand, it also cannot be ambidentate. So we are only left with thiocyanate, which is SCN minus, which has donor site as nitrogen and sulfur. Next, 2A plus B will give me 2D gaseous. I'm provided with change in internal energy, entropy, and I need to find the correct option with delta G for reaction and spontaneity for this reaction. So for this, we can use, we are provided with delta U, delta S. All are gaseous. Correct option R. Delta S is given by what? dq by dt at constant reaction following, it is a gas. If gaseous, all gaseous reaction will have constant volume, so it will be Cv dt, but heat capacity I'm not provided for the gas. S by dt. Wait, we can directly use for the enthalpy criteria using entropy of the system is decreasing from 3 molecules. I am going to the other direction, 3 to 2. Entropy is decreasing, and for the expression delta G is equals to delta H minus T delta S. If entropy is decreasing, so that means this value is becoming highly positive. If it is becoming positive, delta G will decrease, and the temperature is also low, delta S. So delta G using this, and enthalpy will be here, delta H will be equals to delta U at constant volume. So I can use it as delta U, which is also, this is negative. If I use combining these two criteria, the overall, and this is 44, this is just 10. So overall the process is non-spontaneous. So spontaneous options are out. Next, we are provided with delta S. Delta S will be delta U by T. Solving it will be 10 by 298. It will be lesser than 1. So only option number 2 is correct. We are provided with correct formula charge. Ozone is given. This will be 0, this will be +1, this will be -1. Given below are certain reactions. Identify the reaction for which Kp won't be equals to Kc. For Kp being equals to Kc, the only condition is that delta Ng should be equals to 0. Delta Ng should be equals to 0. So 2, 1. For both are equal, number of moles of 1, 1. This is 2. For it will be Kp equals to Kc. For 1, 1, 2. For which it is also 1 plus 3, 4. It is giving 2. For this, the reaction Kp and Kc won't be equal. For combination of N2 plus 3H2 giving 2 moles of ammonia. Next is, given below is the expression for the rate constant of first order reaction occurring at temperature this. We need to find the energy of activation in kilocalories per mole. So K is given by A minus EA by RT. ln K will become ln A minus EA by RT. This is ln A. Energy of activation is EA, which is minus 1.25, 10 power raised to 4. 10 power raised to minus 4. They have given temperature in Kelvin. EA would by default would be provided you in joules. So for conversion rule, now you need to remember that 1.25 multiplied 10 power raised to 4. This would be, for conversion unit, this in joule. 1 joule will be provided to you as 24.48. 24.48, and this is the value of wait, I need to divide it by R as well, this EA by R. So dividing 1.25 by 10 power raised to 4 by 1.987, I'm converting 1.25 into, assuming it to be 1.6, and 1.9 I'm assuming to be 2 for the ease of solving. Dividing, it will be 0.6310 multiplied by 4. This is calorie per mole, and the question is asking me for in kilocalorie, and this is 0.63. So 0.63 multiplied by 10 will turn to 6.3, multiply 10 power 3. This is calorie. 10 power 10 multiplied by 3 will make it kilocalorie. So correct answer should be, wait, R is 1.87, 1.25, 10 power raised to 4 ln A. The value of 1.9 by R will be 2. It's 6.3 around 1.26, or there's something change. For a first order reaction, R is provided to us as this. It's coming nearly 4 times, so 1.25 times of R, which is 1.97, which is nearly 2. 12 goes 6, 6, and this would be 3.63. It is nearly 4 times of the original value. ln k, ln. Wait, there should also be 2.303, but this is just ln. So for ln, I don't need to divide by 2.303. ln k 14.3, ln k 14.3. This is the entire value of ln A, 1.510 t, r 1.97, 1.25 kilocalorie. Oh, this is in joule. This is in joule, and 1 joule is about 4.28 calories. 4.28. So 6.3 multiplied by 4.8 will give me 24.8. This will be the correct answer, option number 4. Then following are the two reactions which give same foul smelling product Z. Ethyl chloride reacts with some reagent, gives you Z. Then one of the product it forms, then it is ethylamide, reacts with Br2NaOH, forms Y, then chloroform, ethanolic KOH. What would be the X and Y? What would be X and Z that are formed? First thing, any amide react with Br2NaOH. This is Hoffman bromamide degradation, which will give you ethylamine, which is C2H5NH2, which when react with chloroform in ethanoic acid, it will give you product Z, which is isocyanide. Isocyanide, this won't be, this is not isocyanide, this is not isocyanide, so I'm only left with this and this. So ethyl chloride reacts in presence of Z. So if I want isocyanide, I need to react it with what? If I'm getting Z. So remember, you have two options. Either you can take AgCN or you can take KCN. When you take KCN, KCN being an ionic compound, both nitrogen and carbon can react. And since carbon-carbon bonds are much stronger, here carbon reacts and the overall product would be a normal cyanide. So for isocyanide, I require AgCN. Why? Because the electrons of the AgCN are bound in carbon. Why? Because this is a covalent compound, so only nitrogen can react, which will give me isocyanide. So correct option would be 4. Finally, again we have provided with reagents. We are provided with optical and so let's look for isomerism. For isomerism linkage, if we have ambidendate, we can have linkage isomerism. Ambidendate ligand is found only in C, which is for NO2. So C, option 4, C4, 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 C4 not, C4 not, C4 not. So correct option would be 3. That means A will be 3, PTCHNH3 will be geometrical isomers. Any chelating ligand will always be optical, and Cr2H2 whole 6 will give you your solvate isomerism. So that's it. With this, we have solved the entire NEET paper analysis. You have seen that the questions are not very tough. They are very easy and you can easily solve them. And most of the questions are designed in such a manner that you need to apply just the logic.